include the options of the program, like for example, the number of working threads that the program is configured to run with. And similarly, configuration also might include the parameters of the workload. Like for example, if you have a web server, the configuration might also include the number of requests the server receives every second from the load balancer. So the configuration might include many different parameters in this case. To give you an example why it's challenging, so let's just imagine that you have to configure a web server. So you want your web server to have a high throughput, but at the same time you want to have it a low response time. So you might be asking yourself, how many working threads the web server should have? Or how many requests per second it should receive from the load balancer, so these performance guarantees, they should be fulfilled. So again, given an answer to this task, given a quantitative answer to this task might be a challenging problem, even for a system administrator. Similarly, imagine that you are asking yourself again a what-if question. Suppose that you are trying to deploy an application, like a scientific computing application, and you want to increase the performance of this application by buying a more powerful CPU with 2 times more cores than the current one. So again, you might be asking yourself, how much improvement I will get out of it? Will it going to be a 2-fold improvement as well, or it's going to be less than that, or it's going to be more than that? So again, answering this question is really hard, because the answer on the question depends on many factors. It depends, for example, on the architecture of the program, on its properties, on its resource demands. It depends on the parameters of the workload you are subjecting your system to. It depends on the parameters of the hardware, like I say, the characteristics of the hard drive or the number of CPU cores. And definitely it depends on the configuration options of the program as well. So as I said, that answering this question just by guessing or by some hidden knowledge can be really hard. And a good solution to such problem would be building a performance model of the system. Hopefully you will be building this model either automatically or with a minimum effort, so you won't spend much time on building this model. And then this model will act as an oracle to you. So for each configuration, for each combination of configuration parameters, the model will predict the performance of the system. And then based on this information, the analyst or system administrator can take certain actions. Performance models, they have many usages currently in software engineering. So they use it to automatically deploy programs in a cloud, in a data centers. They use to discover performance anomalies in a running system. They are used to, for example, to answer what-if questions, like something that we described above, to detect performance bottleneck or performance problems in the system early during the development cycle. So this leads us to the main topic of our thesis. So in this thesis, we demonstrate that performance models of large multi-threaded programs can be built automatically.